Imagine a rainstorm that doesn't stop for a million years. Not a wet decade, not a wet century. A single, sustained climate shift that soaked the entire planet for so long that when it finally ended, the world underneath looked almost nothing like the one that existed before it started. This actually happened. Roughly 232 million years ago, Earth spent somewhere between 1 and 2 million years locked in an extraordinarily wet phase, and the fallout from it may have helped decide who would eventually rule the planet. Geologists call it the Carnian Pluvial Event, and for most of the 20th century, nobody even knew it happened. The story of its discovery starts, strangely enough, with confusion. In the 1970s and 80s, geologists working in scattered locations across Europe kept running into the same odd puzzle. Buried within otherwise dry, reddish desert-formed rock layers, dating to the Carnian age of the Triassic period, they kept finding thick bands of grey and black sediment, the kind typically associated with rivers, lakes, and heavy, sustained rainfall. Not a thin, easily explained layer either. A substantial, unmistakable band sitting right in the middle of rock that told an otherwise consistently dry story. For a while, these bands were treated as strange regional anomalies, curious but disconnected. That changed when researchers, including geologist Ruffell, began piecing together similar bands from wildly separated locations, the Eastern Alps, the United Kingdom, and eventually sites across multiple continents. The pattern wasn't local, it was global. Something had briefly, dramatically wet an entire dry world, all at roughly the same time. So what actually caused a sustained, planet-wide downpour lasting over a million years? The leading explanation points toward one of the largest volcanic events in Earth's history, a massive eruption episode known as the Rangelia Flood. Basalts, enormous volumes of volcanic gas, primarily carbon dioxide, were pumped into the atmosphere over an extended period. This triggered a strong greenhouse effect, warming the oceans and atmosphere considerably. Here's the part that connects directly to global rainfall. A warmer world evaporates dramatically more moisture from its oceans. More moisture in the atmosphere means more fuel for monsoon systems, and Pangaea, the single supercontinent that existed at the time, was already geographically primed for intense monsoon activity, with moist ocean air pulled deep into its interior, cooling and dumping enormous volumes of rain across the landscape. Researcher Dal Corso and colleagues have argued the timing lines up precisely with a documented spike in atmospheric carbon dioxide and a corresponding shift in ocean chemistry, evidence pulled from carbon isotope signatures preserved directly in the rock record. The volcanic trigger, the warming, and the sustained rainfall all appear to align on the same geological timeline, rather than being separate coincidental events. Now here's where the story becomes genuinely consequential rather than just a strange climate footnote. The Carnian Pluvial Event coincides with one of the more significant, if historically underappreciated, extinction events in Earth's history. Marine life took a substantial hit. Many reptile groups that had dominated ecosystems up to that point struggled or vanished entirely. The sudden climate whiplash, first extreme heat and rainfall, then an eventual return to drier conditions, appears to have been more than many existing species could adapt to in time. But extinction events rarely just clear space randomly. They tend to open opportunities for whichever groups happen to already have the right traits for what comes next. And this is exactly where dinosaurs enter the picture. Fossil evidence suggests dinosaurs existed in relatively small, unremarkable numbers before the Carnian Pluvial Event, a minor group scattered among many other competing reptile lineages. In the aftermath, that picture shifts noticeably. Dinosaur diversity and abundance appear to expand substantially in the geological record that follows, coinciding with the extinction pressure that thinned out much of their competition. Some researchers argue the Carnian Pluvial Event may have functioned as a kind of ecological reset button, clearing crowded niches at precisely the moment a lineage suited to the emerging conditions was positioned to expand into them. It's worth being careful here. Correlation in the fossil record isn't automatically causation, and scientists studying this period continue actively debating exactly how much credit the Carnian Pluvial Event deserves for the dinosaurs' later dominance versus other contributing factors. But the timing is striking enough that it's become a central piece of the conversation around one of the most consequential shifts in the history of life on Earth. So, why does any of this matter to you, sitting comfortably in a climate that has never delivered a million years of continuous monsoon? Because it's a genuinely humbling reminder of how much of the world you take for granted, including which animals happen to survive long enough to eventually evolve into the ones you recognize today, may trace back to a single sustained climate event most people have never even heard of. Earth's history isn't just a smooth, gradual story. It's occasionally interrupted by genuinely strange, planet-altering episodes, written in unassuming grey rock bands, waiting patiently for someone curious enough to notice the pattern. Somewhere beneath your feet, in rock layers, most people will walk over without a second thought, sits the physical record of a rainstorm that reshaped which animals got to inherit the planet.